This is number 145 in the quant book, and it's problem solving. And what we have is 3 tangent circles. 1, that's not very good. 2, and 3. And I've got the centers there. And I'm going to draw a solid line. And what I'd like for you to realize is that this is a radius of the circle, and then here's another radius. So the length of this side would be 2r. That's one thing I'd like for you to think about. Now they tell me the area of this area here is 64 square root 3 minus 32 pi. So I want to try to find an equation where I can use that. Now I want you to think about this. If I was to find the area of this triangle, area that whole thing, and then if I was to subtract off these little pieces inside the circle, which are all equal, even though my graph doesn't look that way, I would be left with a shaded region. So what I want to do is find the area of the triangle, minus area of those sectors, and that's going to equal the shaded region. So let's think about how we find the area of that triangle. We'll put it all together. Area of the triangle. If I look at this triangle, I'm going to drop a perpendicular down. And I know this here is R and that's R. So this side over here is 2R. And I know that's R, so that's R. So we can use Pythagorean theorem to find the height of this triangle. Because you know when you find the area of a triangle, it's 1/2 base times height. So that's going to be, let's call this x. That's going to be x squared plus r squared equal 4r squared. And that's x squared equal 3r squared. I'm solving for x. And that's x equals the square root of 3 and an r. Square root of r squared is r. So now I can find the area of that triangle. The area of that triangle will be area equals 1/2 base times height. Area is going to be 1/2, well, the base is r, right? Well, I'm sorry, this area of this whole thing. So you got an r there and an r there. So the base of that triangle is 2r. And then the height is what I just found, square root of 3r. So these 2's cancel, and the area of that triangle is going to be, looks like square root of 3r squared. Square root of 3r squared. Now, this is an equilateral triangle. All 3 sides are equal. So we know, what's the measure of this angle here? Well, a triangle has 180 degrees. If it's an equilateral triangle, all the angles will be the same. So each one will be 60 degrees. So this sector here is how much, what proportion of the circle? Well, it would be 60 over 360, which is the same thing as 1/6. So what I have now, so the area of this whole circle, area of that whole circle would be, well, area of a circle is pi r squared. So that area would be, the whole thing is pi r squared, but this sector here is only 1/6. So it's 1/6 pi r squared. But how many of these sectors do we have? We have 3 of them. So I need to multiply that by 3. 3 times a 1/6 pi r squared is 1/2 pi r squared. Let's go back to our original formula. What was the area of the triangle? The area of the triangle is square root of 3r squared. Square root 3r squared minus the area of the sectors, which is this piece here, minus, come on, pen, minus 1/2, hold on a second, minus 1/2 what? Pi r squared. 1/2 pi r squared. And that's going to equal that 64 stuff, but I don't have room here. Let's go to another slide before we do the math. So I've got square root of 3r squared minus 1/2 pi r squared equals 64 square root of 3 minus 32 pi. Okay, so I think what I'm going to, we want to solve for what? We're trying to find the radius. So let's factor out an r squared. If I factor out an r squared on the left-hand side, I'm left with square root of 3 minus 1/2 pi. Now, if you look, I've got a square root of 3 here, and I've got a square root of 3 here. So what I need to do on the right-hand side is to take out a 64. Watch what happens. If I factor out a 64, that's going to leave me a square root of 3 minus 32 over 64, which is 1/2 pi. So look, divide both sides by that, and you're left with r squared equals 64, or r equals, it'd be plus or minus 8, but the radius has to be positive. So the radius is 8.